So the second thing that we want to be able to do with sets after ordering a set is being able to write one. Okay, and there's several different ways that we can write a set of numbers, and most of them you know already. Like you can write a set of numbers using a number line. You can write a set of numbers using an inequality. You can write a set of numbers out in words. One really cool, compact method of writing out a set of numbers that you haven't done before, though, is something that's called interval notation. Okay, and so for any of you who end up taking pre-calc or calc down the line, you'll use interval notation a lot because it's so compact and it's so simple, and it's really not hard to learn either. Okay, so interval notation is taking and describing a set using just the starting and ending points. So it's when you have a set of numbers that just kind of keeps going. So you have not only the number, but all the decimals in between. Okay? Interval notation works great because it just tells you, hey, where did I start? Where did I finish? Okay? And then it also says what's happening at those endpoints. Okay? So if those endpoints are included, so if it's something where there's an equals going on, or a closed circle where it's filled in, okay? If those endpoints are included, we use a bracket. Okay, so we put a bracket on that number, and I think of a bracket as like grabbing onto the number, like we can actually equal it, we can actually have it. Okay, if the numbers on the ends are not included, so if it's just a regular greater than or less than situation, okay, in those, we use a parenthesis. And I always think of a parenthesis as like coming right up to the number, but not actually making it. So kind of like rounding it off, getting as close as you can, but not actually getting there. Okay, so we use brackets when we're equal. And when we're including the endpoint, we use parentheses when we're not. So when there's no equal sign there. Okay, so greater than or equal to, bracket, regular old greater than, parentheses. Okay, and then the one minor point, actually it's pretty big, but just a point to kind of dig out of it. If it's an infinity situation, so if the numbers just keep going for forever, okay, that's always a parenthesis on whichever side the infinity is on. Okay, so if the list keeps going forever, you're always going to use a parenthesis because infinity is not an actual number, so that number is not actually included. Okay, so I just wrote up 4 examples that should match the ones in skill 2 of the assignment pretty closely. They're scrambled a little bit, but all I want to do for all these is write each of these sets in interval notation. So tell me, what's the starting point, what's the ending point, and what's happening on those points. Okay. And as we do this, it's going to look kind of like an ordered pair, like a graph, like a set of numbers that you're graphing, okay, which is fine. It just takes a little getting used to seeing it that way. Okay, so like in this set, the numbers that are shaded in, the numbers that I'm looking at in that set, where do they start? Well, they start at -3. -3 is the first thing that's included. So they start at -3. Where do they end? Well, they go up to 5. So this set of numbers goes from -3 to 5. So -3 to 5. And then we look at what are the ends doing. Okay, is the -3 included in my set? Yeah, because when I have a number line, anything that's shaded in is included, anything that's not shaded in is not. So since the -3 is shaded in, it is included. That is equal to -3. So I'm going to use a bracket on the -3. Okay, and then look at the 5. Okay, is the 5 included? No. Okay, an open circle means you're not equal to. An open circle, not included, not equal to, use a parenthesis. And so we've written our first interval in interval notation. Okay, very simple, and once you've done it a handful of times, it's really easy to read. It just says we're going from 3 or -3 to 5. The -3 is included, the 5 is not. Okay, so again, mathematicians, especially the further up you go, really like this because it takes very little writing and it says everything it needs to say. Okay, so we'll try another fairly simple one for example 2. Where does it start? Where does it end? Okay, so the x is pinched between the numbers 9 and 15. Okay, so where does it start? We always start at the smaller number. Okay, so we start at 9 and go up to 15. This set of numbers goes from 9 to 15. Is the 9 included? Well, it's equal to. So yeah, that's equal to. The 9 is included. Use the bracket. The 15 is also equal to. So also bracket. So these are the numbers that go from 9 to 15, including both of them. And so what is this set? This set is actually the set of stripes from the set of pool balls. From 9 to 15, including both of them, are the set of stripes. Okay. Example 3 and 4, that starts to bring infinity, or like one that just keeps going into it. Again, not a big deal. We just want to go from smallest to biggest. Okay, so in this set of numbers, what is the smallest number that's being shaded? The smallest number that's included? Well, the arrow is shaded. It just keeps going. There is no number on this end. So you start thinking, what is the smallest number I could ever think of? Well, if the biggest number I could ever think of is infinity, the smallest number I could ever think of, we describe with negative infinity. The most negative number ever. Okay. So where does this start? The smallest thing that's shaded is negative infinity. It goes all the way up to 2. So from smallest to biggest. The infinity, does it get a bracket or a parenthesis? Well, infinity is always a parenthesis because we're never actually including infinity because it's not an actual number. So that's a parenthesis. Is the 2 included? Well, yeah, it's shaded in. So including the 2. So from negative infinity up to 2, including the 2. That's what this set of numbers is. From negative infinity up to 2, including the 2. And so the last one, with an inequality, the x's, so the numbers that are greater than 8. Okay, so the numbers that are greater than 8, where do they start? Okay. If you can visualize that in your head, awesome. If you can't, you can always just make yourself a little drawing. So here's 8. It's not equal to, so it's an open circle. Where are the numbers that are greater than 8? Well, numbers that are greater than 8 are over here. So the set of numbers greater than 8 start at 8. And they go up for forever. And if they keep going up for forever, they're going all the way to infinity. Okay. Is the 8 included? Nope, it's not. Have to see. And infinity is never included. So there you go. Each one of these guys is an interval. Starting point, ending point, and what's happening at those ends. Okay. And so with a little practice, you can get used to interval notation pretty quickly.